Let's see it for some time. Yeah, good afternoon everybody. So myself, Vishwanath, a chemistry teacher, and with 14 years of experience in teaching NEET and JEE, and worked with various organizations in India, okay, and produced a lot of rank in medical as well as JEE and advanced. So my best results in advanced is 175 rank in 2018, and most of my students, they got selected in MBBS. So for example, in the case of 2020 NEET also, most of my students, they got the 600 plus, the people who got 600 plus marks side is more than 50 people. So that means we have a plan to produce good marks in a NEET exam. So based on that work, if you work properly, if you want to achieve the NEET really, then we are here to help you, and we will help you, and we will make you to get the good rank in the NEET exam. So the only thing from you is discipline and hard work, and you have to work hard and you have to cooperate with us. So we have a schedule, we have a plan, okay, so everything we have. So that is, you have to cooperate with our schedule. By this one, whenever you are following my schedule, an average student can get 160 marks in chemistry. I am sure about it. Chemistry after bio, you can score 160 marks easily in chemistry if you follow the schedule which is given by me. I will give a schedule to you to how to read and how to solve the problems and all these things. See, every year by year, the question paper standards are decreasing. That means the number of marks going to score is also increases. See, in the examination 2020, the top marks is 720. So that means what? Year by year, the number of marks is going to increase, the cutoff marks is going to increase. So there is no doubt at all in the 2021 also, the NEET exam will be very easy, and the cutoff marks you can expect 650 easily. So why these things are happening? So the thing is, the examiner want to give the paper easy and he want to increase the marks. And we cannot say, as our NCERT, we cannot say this is important and this is not important. We have a blueprint like this for this chapter. Okay, we have to concentrate on this chapter like this. For a competitive exam, there is no blueprint like that. Okay, an examiner always want to cover the entire syllabus which is present in the book. Okay, so don't think like that. We have to focus on the difficult things. We will get the questions from difficult part only like that. Okay, see, if you see the 2020 NEET exam, most of the questions from NCERT and NCERT exemplar, and most of the questions are just like copy paste. So that means what? What is the intention of examiner? So the intention of examiner is what? The intention of examiner is he want to give questions from all the part of and for all the corners of the textbook. Okay, so for this one, you have to know how to read the NCERT and how to solve the NCERT questions and how to solve the NCERT exemplar questions. So first you have to practice all these things, and these things we will give a coaching. So in this coaching, apart from this NCERT questions and NCERT examples, we will give numericals and shortcuts, how to solve the questions and all. Okay, and we will focus to minimize the mistakes done by you. Okay, so we have regular exams and regular doubt clarification sessions. Okay, and we have personal concentration on each student. Okay, so we will try to minimize the mistakes what are doing by your people, and we will help you to perform well, and we will help you to crack the NEET rank easily within span of 6 months. We have a schedule of 6 months. If you follow this schedule for 6 months, okay, surely an average student can crack the NEET. There is no doubt at all. So be confident on you and be trust. Okay, so you have to believe your teacher, believe your schedule, believe your timetable, believe your exams pattern, and all these things. We are here to make you better, and we are surely we will make you to qualify the NEET exam, and you will get seat in a better college. Okay. So the thing is, in today's class I am going to discuss very basic thing of organic chemistry. So it is a basic thing, even though it is a basic thing and very easy thing. In this chapter, every year, most of the years, you will get at least a single question from this chapter. So that means, what does it mean? Suppose if you are perfect with this chapter, 4 marks is in your pocket at least. This IUPAC nomenclature is not only useful for 11th standard, this IUPAC nomenclature is useful for 12th standard people also and for repeaters also. So while you are studying for your 11th standard, okay, so I don't know whether you studied about this IUPAC nomenclature clearly or not. In today's class, I will give some basics of this IUPAC nomenclature class, okay, and after this class, I will give you some questions to do, okay, and we'll conduct some quiz, okay. So like this, in every day we'll do a new topic, okay, and it will make you to understand, and the topic will be very useful to you and you can do well. And the thing is, and I am asking you one more thing, I am requesting you, be confident on yourself and be confident on your teacher, believe your teacher, do work hard, and easily you can achieve the rank, that is good rank in NEET. So your marks will be more than 650 by the NEET 2021, no doubt at all. Okay, be sure you can get the good marks in NEET if you follow our schedule and if you take our exams. Okay, so now we'll start our class. The class is IUPAC nomenclature of organic compounds. IUPAC nomenclature of organic compounds is an important topic for every competitive exam like NEET and JEE, advanced, whatever it may be. So you can find a single question, at least a single question for every year in the NEET, JEE and advanced papers. Okay. So then the thing is, we'll start with this one. So IUPAC nomenclature of organic compounds, this is syllabus of 11th standard. Even though it is a syllabus of 11th standard, we have lot of applications of this one in the 12th standard also. So IUPAC nomenclature of organic compounds. So this, for the nomenclature of any organic compound, there is a system is there. Based on that system, the nomenclature can be given. Okay, so for that IUPAC has given some guidelines. What is that IUPAC? The IUPAC is International Union for Pure and Applied Chemistry. So this will give some guidelines to name a compound. That means each compound will have only one particular name. So why this is IUPAC is so useful in organic chemistry is, in organic chemistry we have numerous number of organic compounds. As we have numerous number of organic compounds, because of that reason every compound should have its unique name. Because of that reason, you have to follow the IUPAC guidelines. Based on the IUPAC guidelines, you can give a name to any organic compound easily. Then, yes. So then coming to IUPAC nomenclature of organic compound. So first one, alkanes nomenclature. So the alkanes is nothing but an example of saturated organic compound. So it is example of saturated organic compounds. So saturated means what? Saturated and unsaturated. So this is saturated. This is an example of saturated hydrocarbon. This is an example of. So alkanes nomenclature, the name of every molecule has 3 parts. Strictly speaking, the name of organic molecule, that is, if you have a small molecule, it have minimum 3 parts. But whenever you are speaking about this one, so exactly if you want to speak strictly, the organic compound, which is a complex organic compound, it will have secondary prefix plus primary prefix plus root word plus primary suffix plus secondary suffix. If organic compound is simple compound, then you can have one suffix, one parent and one prefix. Whenever the organic compound is complex one, then the structural formula of organic compound will be like this. So, secondary prefix, primary prefix, root word plus primary suffix and secondary suffix. Okay. See, the suffix indicates what functional group is present. This secondary suffix is there, no? This secondary suffix, this indicates what is the functional group present in the organic compound. And coming to root word, this indicates number of carbon atoms present in the parent chain or main chain. So, how we have to choose the parent chain, that is different case. Okay. Then the thing is, so the parent chain indicates the number of carbons in the longest continuous chain. So, this will be come to know from word root or root word. Word root. Okay. And the suffix indicates what functional group is present. This indicates what functional group is present. And the prefix tell us the identity, location and number of substituent attached to the carbon chain. So, that means a prefix always speak about the substitution only. The prefix always speak about substitution only. The secondary suffix, it is used to know whether the compound is which functional group we have, and the primary suffix, it is used to whether the compound is saturated or unsaturated. A root word indicates number of carbons. Secondary prefix, it indicates substitution, and primary prefix, it indicates the nature of cyclic compound, whether it is cyclic compound, bicyclo or what else may be. So, like that, so the compound will have this structure: secondary prefix, primary prefix, root word, primary suffix and secondary suffix. So, here what is prefix, what and where are the substituents. So, that means it gives the position of the substitution as well as the name of the substitution. And parent chain, this will give how many number of carbons you have, in the parent chain. This will be given by this one, parent chain. And suffix, and the suffix will give what is the functional group present in the organic compound. So, that means whether it is alcohol, carboxylic acid, amine, amide, ketone, aldehyde. Okay. So, like this it will deals about the functional group, what functional group is present in the that particular organic compound, that it will deal about. Okay. See, parent longest straight chain. See the root word. Suppose if you have one carbon in the parent chain. For example, if you have one carbon in the parent chain, then that is called as meth. If you have one carbon, that is meth. If it is alkane, methane. Suppose if you have one carbon, this is meth. This is meth. If it is alkane, you have to add ane. Methane. If you have one carbon and it is alkane, the name of the compound is methane. And if you have two carbons, then this is stands for eth. Eth means, and if it is alkane, we are discussing about alkanes, that is ethane. Two carbons stands for eth. Three carbons, prop, but, pent, hex, hept, oct, non, dec, eicosine, like this. Okay. So, and number of constitutional isomers. Suppose whenever you have methane, we cannot write the isomers for methane. Okay. See, this is the structure of methane. We have only one carbon, so we cannot write any structure for this one. So, the number of constitutional isomers, there is no number of constitutional isomers. Similarly, come to methane. Ethane, so this ethane is having 2 carbons, CH3, CH3. So whenever you have CH3, CH3, here also it is not possible to write the isomers. And coming to propane, the propane you have 3 carbons. So even though it have 3 carbons, it is not possible to write the constitutional isomers. The structure of propane is like this: CH3, CH2, CH3. Okay, so we cannot write the isomer for this propane also. So we don't have constitutional isomers for methane as well as for ethane as well as for propane also. Okay. Next, coming to butane. So the butane have how many carbons? The butane have 4 carbons. So the butane have 4 carbons. As the butane have 4 carbons, see then how many isomers can we write? Let me give an example. So the butane is what? So the butane is this one, CH3, CH2, CH2, CH3. This is butane. We have 4 carbons, butane. And what is the isomer of this one? So we can write one isomer for this one. What is the isomer for this one? The isomer for this one we can write CH3, CH, CH3, CH3. So the name of this one is N-butane. N-butane, and this is 2-methyl propane. 2-methyl propane. Okay, so like this, a butane can be written 2 structural isomers. For butane, you can write 2 structural isomers. So in similar way, a pentane, for pentane you can write 3 isomers. For pentane you can write 3 isomers. And for hexane you can write 5 isomers. And for heptane you can write 9 isomers. And for this one 18, 35, 75, like this. As the number of carbons increases, the number of isomers also increases. Understand? So this is the case whenever you are going to write the root word. So the root word indicates what? The root word indicates number of carbon atoms present in the main chain. So that will be indicated by a root word. Okay. So 1 eth 2 sorry 1 meth 2 eth 3 prop 4 but 5 penta 6 hex 7 hepta 8 oct 9 non 10 dec. So like this. So this is very easy one. Okay. So remembering root words is very easy. Okay. After this, see suffix. The suffix indicates our functional group is alkane, so that suffix is ane. So this is what type of suffix this is? This is primary suffix. Primary suffix. So primary suffix indicates, this primary suffix indicates whether the compound is saturated or unsaturated. So our primary suffix is ane. Okay, so it is a saturated compound. Okay, so CH4 methane, C2H6 ethane, C3H8 propane, butane, pentane, hexane, heptane, octane, nonane, decane, undecane, dodecane, like this. And the general formula for this alkanes is CnH2n plus 2. So this is the general formula of alkane, CnH2n plus 2. Okay. If you have methane, this methane have only one carbon, ethane have 2 carbons, propane have 3 carbons, butane have 4 carbons, pentane have 5 carbons, hexane have 6 carbons, heptane have 7 carbons, octane 8, nonane 9, decane 10, undecane 11, dodecane 12. So, and these two are called as homologous series. These two are called as homologous series. So, the homologous series are having same functional group, but they are differed by one CH2 group. Whenever they are differed by one CH2 group, so this is differed by one CH2 group and the molar mass is differed by 14 units. And the molar mass is differed by 14 units. How the molar mass is differed by 14 units? So this carbon is 12 and for this hydrogen 2, 12 plus 2 is 14. So these two are differed by 1 CH2 and these two are differed by 1 CH2, these two are differed by 1 CH2, these two are differed by 1 CH2, these two are differed by 1 CH2 and these two are differed by 1 CH2. 1 CH2, 1 CH2, 1 CH2. So this series is called as what? If you have a series like this series is called as homologous series. Understand? Clear about the homologous series? Yes. Prefix. So prefix, our substituents will be the branches in the alkane structure. So that means the prefix is always stands for a substitution. Okay, remember the prefix is always stands for a substitution. Okay, so then it may be primary prefix or a secondary prefix. If you are using the word prefix, it means it stands for a substitution itself. Be clear in this case. Okay, a branch is another alkane minus one hydrogen is called as an alkyl group. For example, if you have an alkane like CH4, for example, if you have an alkane like CH4, if you remove one hydrogen from this CH4, if you remove one hydrogen from this CH4, you will get CH3. This is called as methane. And this is called as methyl, and this is called as methyl, methane, methyl. So that means the general formula of any alkyl group you can written as CnH2n plus 1. So the general formula of any alkyl group you can written CnH2n plus 1. So that means an alkyl group you can get by addition, by removal of an hydrogen from alkane. So that means in general what you can write? In general what you can write? Alkane by removal of hydrogen you will get alkyl. Okay, if the alkyl is from methane, you can call it as methyl. Methyl. If the alkyl is from ethane, then this is stands for ethyl. If the alkyl is from propyl, it can be named as C3H7. If this is from propane, you can name it as propyl, like this. Okay, propane, propyl, ethane, ethyl, methane, methyl. So like that, by removal of hydrogen you will get an alkyl group. Understand? So that's clear. Yeah. Next, since it is a side chain, it will replace ane suffix with the "-ile". Okay. So the ene is going to replace with "-ile". So actually it was methane, it is replaced with the methyl. It was ethane, after removal of hydrogen I got ethyl. It was propane, after removal of hydrogen I got propyl. Understand? So like this you can get an alkyl group. Okay. And if methyl is there, no, so the methyl can be written as Me. Suppose if you have ethyl, C2H5, the C2H5 you can written as ethyl. Okay. If we have C2H7, sorry, C3H7, you can write propyl. If you have a branch, you can write isopropyl. If you have butane, you can write butyl. If you have substitution at second position, you can write secondary butyl. If you have tertiary, that means if that butyl group is having 3 carbons, that is tertiary carbon, you can call it as tertiary butyl. So what is the tertiary butyl? For example, if you have 4 carbons like this, for example, if you have 4 carbons like this, you can name this as tertiary butyl, T but, you can name like this, tertiary butyl. So that means an alkane, by removal of a hydrogen you can get alkyl group. Just remember that one. Okay. Whether it may be methyl, ethyl, propyl, butyl, pentyl, hexyl, heptyl, octyl, whatever it may be, just keep in this in your brain. And that is a branch. Okay. For example, if I have a compound like, for example, I will give you a compound, I will give an example to make you explain how it is a substitution. Okay. See, for example, if you have a compound like this, okay, for example, if you have a organic compound like this, whenever you have an organic compound like this, according to our first rule, what is the first rule? You have to choose the longest chain. So according to our first rule, you have to choose the chain. That means a chain with more number of carbons is called as longest chain. Now suppose, let me see, 1, 2, 3, 4, 5, 6. Suppose if this is your main chain, we have 6 carbons. Suppose if you name like this, or if you give the numbering like this, so we have only 5 carbons. So because of this reason, so this is a main chain, this is main chain, and this is substitution, and the substitution is present at where? Whenever you are giving the numbering, the substitution should get the lowest number, that is called as lowest locant rule. So 1, 2, 3. At third position we have a substitution. What is the substitution? Methyl substitution is there. Then what is the name of the compound? Yeah, what is the name of the compound? Yes, please respond. What is the name of the compound? Yeah, 3-methyl hexane. 3-methyl hexane. 3-methyl hexane. So the substitution, whenever we have substitution CH3, we can call it as methyl. Understand now? So CH3 is a branch of longer chain. So this is a longer chain and CH3 is a branch of a longer chain. So because of that reason, we can consider this one as a substitution and we are naming it as methyl. Suppose if we have C2H5, we can call it as ethyl. Understand? Right. See prefixes, that means substitution. If you have CH3 substitution, this is CH3 and IUPAC name methyl and abbreviation Me and abbreviation Me. Okay, and if you have CH3 CH2, the structure is this one. So whenever you are writing structure like this, what you have to see? So that means this is CH3 and this is CH2. This is called as ethyl, indicated with the Et. This is propyl, we have 3 carbons. N propyl, what does mean by N? N is means normal. So there is no branches over there. You have only a straight chain. Then this is called as N. Okay na? And this one is isopropyl. Why this is called as isopropyl? So the reason is this is a main chain. This is a main chain. For this main chain we have a branch here. Because of that reason, this is called as isopropyl or I-propyl. It can be indicated by I-propyl. Okay, and this is what? This is N-butyl, normal chain, N-butyl. So this can be indicated with the NBU. Secondary butyl, see this is secondary carbon. What is meant by secondary? Primary, tertiary. We can name it as first degree, second degree and third degree also. What is meant by primary? Suppose if we have a group like this, okay, if the alkyl group is linked with any R, then this is called as primary. So this carbon is primary carbon. Suppose if your carbon is like this, this is called as what? This is called as, yeah, this is called as secondary. So this carbon is called as secondary carbon. Suppose if you have like this, then this is called as tertiary. Then this is called as tertiary or third degree. Tertiary or third degree. Understand? So primary, secondary and tertiary. So whenever if you have a straight chain, this is called as N-butyl, and whenever the linkage is for secondary carbon, this is called as secondary butyl. This is secondary carbon, and this is isobutyl, and this is tertiary butyl. So why 3 carbons is there? 3 carbons is there around this one. So because of this reason, you can call it as tertiary. And phenyl, C6H5 is called as phenyl. Phenyl is nothing but benzene ring. So benzene ring after removal of one hydrogen is called as phenyl. It can be shown as C6H5, phenyl. Okay, understand? So here written as pH, tertiary butyl, isobutyl, secondary butyl, N-butyl, like this. Understand? So like this you can name the prefixes. So here we have the rules. Okay. So the rules is how to find out the principal carbon chain. How to find out the principal carbon chain. So that means which is the main carbon chain we have. So that is the rules we have. See, so find the parent carbon chain and add the suffix. Okay. See here, among these two, which you have to choose as a parent chain. See, for example, if you give the numbering 1, 1, 2, 3, 4, 5, 6, 7, 8. If you give the numbering, you are getting 7 carbons. Suppose if you give the numbering 1, 2, 3, 4, 5, 6, 7 carbons. And if you are getting here, here also you are getting 7 carbons. So because of this reason, in this case only we are going to get 8 carbons. We are going to get 8 carbons. So because of this reason, this is considered as the main chain. This is considered as the main chain. So this main chain have 8 atoms in the longest chain. Whenever you have 8 atoms in the longest chain, what is the root word? What is the root word? So the root word is oct. The root word is oct. And what are the substitutions here? So this is a substitution, this is a substitution, and this is also a substitution. So that means where we have the substitution and from where you have to give the numbering. From where we have to give the numbering. So the substitution should get the lowest number. Based on that one, you have to give the numbering. So that means 1, 2, 3, 4, 5, 6, 7, 8. We have to give the numbering like this. And this is what? This is incorrect. 7 atoms is there. Because of that reason, this is incorrect. Okay. See, there is no condition like the chain should be straight. Okay. So for longest chain, there is no condition like the chain should be straight. Okay. Whatever it may be and how it will be, the number of carbons should be more in the case of longest chain. Remember this one. Okay. See here, we have 8 carbons here. Here also we have 8 carbons. Here also we have 8 carbons. So this is a straight chain like this one, and this is not a straight chain, and this is also not a straight chain. Even though these are not straight chains, this is a principal chain, this is a principal chain, this is also principal chain. As they have more number of carbon atoms, because of that reason they are called as parent chain as well as main chain. Done? Yes. Next. Also note that if there are 2 chains are equal length, pick the chain with more number of substituents. If you have a chain, that means if you have 2 chances of giving the numbering, if you have 2 chances of giving the numbering, then choose a chain with more number of substitutions. Suppose if you choose a chain with 1 substitution and if you choose a chain with 2 substitutions, the priority should be given to what? The priority should be given to the compound which is having 2 substitutions. So the compound which is having more number of substitutions, for that one only you have to give the highest priority whenever you have, whenever you are getting the same number of carbons counting from either side. Okay. So for that one example, see 1, 2, 3, 4, 5, 6, 7. 7 carbons is there. 7 carbons is there. And here 1, 2, 3, 4, 5, 6, 7 carbons is there. What is the main chain now? Suppose if this is main chain, you have only 1 substitution. If this is your main chain, we have 2 substitutions. So as we have 2 substitutions here, this will be considered as the main chain, and this is not a main chain. Why? Here we have only 1 substitution and here we have 2 substitutions. As here we have a 2 substitutions, because of this reason, this is the longest chain and this is the correct one and this is wrong one. So like this, you have to choose a longest chain whenever you have the substitutions are getting more number of substitutions, then that is the main chain. Got it? Yes. So number the atoms in carbon chain to give the first substituent to lowest number. This rule is also called as lowest locant rule. This number is also called as lowest locant rule. Lowest locant rule. Lowest locant rule. So that means what? The substitution should get the lowest number. You have to give the numbering such as the substitution should get the lowest number, that is called as lowest locant rule. So now see the compound. For example, if you give the numbering from this side 1, 2, 3, 4, 5, 6, 7, 8. Suppose if you give the numbering from this side 1, 2, 3. Whenever you are giving the numbering from this side, the substitution is getting at second position, and whenever you are giving the numbering from this side, the substitution is getting at the third position. Because of this reason, so the numbering from this side is the right one and this is wrong one. So here first substituent at second position and here first substituent at the third position. According to our lowest locant rule, the substitution should get the lowest number. Because of that reason, so this will be considered as correct one and this is considered as wrong one. Understand? The substituent should get the lowest number. Okay? Right? If the first substituent is the same, distance from the both sides, number the chain to give the second substituent the lower number. See, suppose if you give the numbering from here, see this compound, numbering from left to right, at second position I am getting the substitution. If the numbering from left to right, at second position I am getting the numbering. Okay, if the numbering is from right to left, I am getting the second position itself. Coming to here, first position and fifth position I have the substitutions 1 and 5, and coming to here 2 and 5, 1, 2, 3, 4, 5. At second position and fifth position I have. Yes, I have here also. Yeah. So we have three substitutions. So see the substitution. Second substitution we have, third substitution and fifth position. So we have three substitutions, second position, third position and fifth position. In such cases you have to go for lowest sum rule. In such cases you have to go for lowest sum rule. What is this lowest sum rule is, whenever we are going to add the positions of all the substitutions, you should get the lowest number. That is called as lowest sum rule. Yeah, see here 2 plus 3 plus 5. 2 plus 3 plus 5. 2 plus 3 plus 5, this is 10. According to lowest sum rule, this is 10. And coming to here, 2 plus 4 plus 5. According to lowest sum rule, this number is 11. So the sum of the substitution should get the lowest number. For such sign you have to choose as a parent chain. So this is according to lowest sum rule. Here we got the 11 and here we got the 10. According to lowest sum rule, this is the main chain and this is not the main chain. Okay, but however, whenever you are going to compare the lowest sum rule and lowest locant rule, the priority should be given to lowest locant rule, and you have to compare with lowest sum rule. Okay, whenever lowest locant rule is same, then you have to go for lowest sum rule. Then the thing will be worked out. Got it? Yeah. and next one. When the numbering of a carbon chain results in the same numbers from either end of chain, assign the lower number alphabetically to the first substituent. Okay. Whenever the lowest locantone is same, you have to give the numbering according to alphabetical order. See here, suppose if you give the numbering 1, 2, 3, ethyl is coming, E is coming. E is coming. Whenever at third position E is coming. At fifth position M is coming. And see here, at third position M is coming, at fifth position E is coming. Here see the lowest sum rule. Whenever you are seeing the lowest sum rule, 3 plus 5 is 8. And here also according to lowest sum rule, 3 plus 5 is equal to 8. In such cases, you have to go for alphabetical order. Understand? In such cases, you have to go for alphabetical order. So that means, from where you have to give the numbering? From this side, you have to give the numbering. So why? Whenever you are comparing the E and M, according to alphabetical order, E will be comes first, and then M will come first. Sorry, and then M will come. Because of this reason, ethyl has to give the priority. So then what is the name of this one? Whenever if you want to name this compound, what you can name? 3-ethyl, 3-ethyl, 5-methyl, heptane. Three-ethyl, 5-methyl heptane. So this is the right one. So similarly, a similar example I will give you. See, for example, if you have CH3, CH, Br, CH2, CH, Cl, CH3. For example, this is your compound. See, suppose if you give the numbering from here, the substitution is getting the second number. Suppose if you are going to give the numbering from here also, so the substitution is getting second number, chlorine is getting the second number. In such cases, what we have to do? We have to go for alphabetical order. So see here the substitution is bromo, B, and here the substitution is chloro, C. So that means from where we have to give the numbering? We have to give the numbering from this side. 1, 2, 3, 4, 5. Then what is the name of the compound? The name of the compound is what? 2-bromo, 4-chloro, 4-chloro, pentane. So this is the name of the organic compound. 2-bromo, 4-chloropentane. So this name is given based on alphabetical order. So like this, whenever the locant is getting the same number, you have to go for alphabetical order. Done? Understood? And name and number the substituent. Name the substituent as alkyl groups. Every carbon belongs to either the longest chain or substituent, not both. Each substituent needs its own number. If two or more identical substituents are bonded to the longest chain, use the prefixes to indicate how many: di for 2 groups, tri for 3 groups, and tetra for 4 groups, and so on. Okay, see, coming to here, here I have a methyl, and here I have ethyl, and here I have methyl. So that means how many methyl groups I have? Yeah, what happened? So here I have methyl and here I have methyl. So that means dimethyl is there and one ethyl is there. So if you want to name the compound, what you have to name it as? So at fifth position we have ethyl. So if you give the numbering 1, 2, 3, 4, 5, 6, 7, 8. So here we have getting the lowest number for the substitution. So you have to give the numbering from this side 1, 2, 3, 4, 5, 5, 6, 7, 8. Okay. So now what you have to give the name for this compound? 5-ethyl so 5-ethyl 5-ethyl. At second position we have methyl, as well as at sixth position we have methyl 2,5 dimethyl 2,5 dimethyl octane. So 5-ethyl 2,6 dimethyl octane. So like this you have to name as di, tri, tetra. Okay na? So like this you can give the name. Next one, combine the substituent names and numbers plus parent and suffix. Precede the name of the parent by the names of the substituents. Alphabetize the names of substituent. Ignore the all prefixes except iso and isopropyl and isobutyl. Precede the name of each substituent by the number that indicates location. Separate numbers by commas and separate numbers from letters by the hyphen. We have to put the commas. You have to put the commas and you have to put the hyphens. So the name of an alkane is a single word with no space after hyphens and commas. So whenever you want to use the commas and hyphens, whenever you are using the substituents, so then only you have to use the commas and hyphens. After completing the commas and hyphens, there is no space for naming the alkanes. Understand? See here 2,6 dimethyl. So 2,6. So methyl is at second position as well as at the sixth position. 2,6 hyphen dimethyl. Okay, 2,6 dimethyl, and then what? 5-ethyl. So whenever you are giving the number, what you have to write? 5-ethyl. According to alphabetical order, E will comes first, no? Because of that reason, 5-ethyl, comma 2,6 dimethyl. So it has come like this. 2,6 dimethyl octane. So like this we have to write the names. Okay. So after these commas and hyphens, there will not be space. So completely you have to write the name of the alkane. Understand? So 5-ethyl 2,6 dimethyl octane. This is parent one. 8 carbons we have. Suffix. This is saturated one. And substituent and numbers. Okay, done. Alkanes. So here we have to discuss about the nomenclature of cycloalkanes. So cycloalkanes, see, strictly speaking, cycloalkanes. So the primary prefix speak about nature of the compound. Okay. So prefix, what and where the substituent, parent, how many carbons are there in, prefix, what is the functional group. Cycloalkanes are used naming by the similar rules, but the prefix is cyclo. So that is what? Primary. Okay. Cyclo immediately precedes the name of the parent. Okay. See, for this C, for example, if you see this compound, this is the parent one. Here we have 6 carbons in the ring. So this is considered as the parent one. And these two are considered as the substitutions. These two are considered as the substitutions. and among these two, this is ethyl and this is methyl. So which one has to come first? E has to come first, right? So give the numbering from this one, 1, 2, 3. So that means 1 ethyl, 3 methyl, 3 methyl cyclohexane. So like this you have to use the numbering. You have to use the substitutions first, and this is the parent chain and this is the substitution. Okay. So 1 ethyl, 3 methyl cyclohexane. Okay. For example, if you have like this is cyclopropane. If you have methyl group like this, it is a methyl cyclopropane. If you have methyl group like this can be called as 1,1 dimethyl cyclopropane. One dimethyl cyclopropane. For example, if you have a compound like this, so here I have 2 carbons as a substitution. So this is what? Ethyl cyclopropane. Ethyl cyclopropane. For example, if you have same number of carbons on same side, here we have 2, 1, 2, 3. Suppose if you have like this is considered as a substitution and this is considered as the main chain. So then how many carbons we have? 3 carbons. So then what you can write? Propyl cyclopropane. Propyl cyclopropane. Propyl cyclopropane. Okay. So like this we can name the organic compounds according to using IUPAC guidelines. See, the IUPAC guidelines is a huge one. Okay. So if you want to discuss detail, it will take more than 6 to 7 hours if you want to discuss in detail. And see, in next class we will discuss about the thing. And if you want to teach, if you have any specific concept, sir, please this concept, if you want any specific concept, please mention in comments, please mention as a comment, then I will teach that particular concept for the next class. Otherwise, I will choose my own topic for the demo. Okay. Hope this is useful for you. So if you feel this video is useful to you, please do like, do share and tell to your friends to join in our next demo classes. Okay. So then it will be helpful to us and it will be what? It will be support to us. Okay. Thank you. Have a nice day. All the best.